This detailed example looks at measures of variability. We're going to be using the random sample of 20 cases from the 2012 General Social Survey. And we're going to use two variables. One will be social class and the other will be education. And so let's just hide all of the variables that we don't want to use. We'll just select the ones that we don't want to use, and then we'll right-click and hit hide. And now we're down to only those that we want to use, class and education. So let's begin with class. What's the appropriate measure of variability for class? Well, because it's an ordinal variable, our only real choice is the index of qualitative variation. So let's calculate the index of qualitative variation. We could calculate this for nominal variables as well, and when we calculate for ordinal variables like class, we're essentially treating them like nominal variables. So let's start with the equation for index of qualitative variation. Going to my Word document, I'm going to type the equation out, and I do that by coming over here to equation, and I'm going to put in a new equation. Okay, so notice that I can type my equation into Microsoft Word here. So I'm going to make the IQV equal to the following values. First, I want to put in some kind of a fraction. So I'm going to click here. And in my numerator, I'm going to type K, which stands for the number of categories, times 100, which I'm going to square by coming up here to where it says script and hitting this value. And notice that I now can put in a square term. And that's minus the sum of the squared percentages. Now to get the summation symbol, I just come up here where it says large operators, and I'm going to hit the summation symbol. And I now have a summation symbol. So I'm going to put in the sum of the percentages, and again I highlight this, and then put in a superscript, squared. And I'm going to end my parentheses. And then in the numerator, I have K minus 1, K being the number of categories, again, times 100 squared. So, I basically have to calculate the sum of the squared percentages. And I can do that by going back to my data. And so the first thing I can do is I can make a pivot table. And so again, if I go to Insert, Pivot Table, I can put it in my existing worksheet right here. Take class. And I'll get the count of class to get the frequency distribution. Okay, what I need to do now is just copy and paste this because of the codes that Excel embeds into it. So if I go here up to copy, paste special, I can just paste the values. And now I can calculate the percentages like we've done before. So I'm just going to take each of these values, divide them by the total number of cases, and multiply that by 100 to get the percentages. And I'm going to do that for all of them by putting a dollar sign next in between the M and the 7, indicating the total. So if I just pull this down, I now have my percentages. I can make sure that they sum to 100. Okay, here they are. So I have my percent right now. Now I need my squared percent. And so what I'm going to do is I'm going to use the equal sign and take each of these percentages and square them. I use a little caret to indicate the squaring operation. And I can, again, put my cursor somewhere here at the bottom of the cell, the bottom right-hand corner, and just pull this down. And then if I take this and take the sum, I'm going to get the sum of the squared percentages, and that comes out to 4,150. So I can plug that number, 4,150, into my formula. And so if I go back to my Word document, if I just copy and paste this, to highlight the whole thing. There we go. Now I can plug in that sum of squared percentages. And so the sum of squared percentages turned out to be 4,150. I had 4 categories for the variable class. That was lower, working, middle, and upper class. So k is going to be equal to 4. 10,000 squared is just going to be equal to 100 squared. I'm sorry, is just going to be equal to 10,000. And my denominator, I'm going to have 100 squared, which again is 10,000, times 4 minus 1, or 3. And so I can continue doing some of the arithmetic here. I'm just going to highlight this and then paste it. And I can do some simplification here. So 10,000 minus 4,150 is going to come out to 5,850. In my denominator, I have 3 times 10,000. So in my numerator, this value is going to come out to 23,400. In my denominator, I'm going to have 30,000. And that's just going to equal 0.78, or 78% if I express it as a percentage. So what does that mean? Well, this tells me that the variable social class exhibits 78% of the maximum possible diversity in the distribution. And so that's a fair amount of diversity in social class. That suggests that there's people reporting various different kinds of classes. Of course, the highest value is going to be 100%, and the lowest value is going to be 0. And this is closer to 100 than it is to 0. So this is a fair bit of diversity in this distribution. Okay, advancing this detailed example forward a little bit, let's look at the measures of variability for the interval ratio variable education. So which are appropriate for this variable? It turns out that's everything but the index of qualitative variation. So that includes the range, the interquartile range, the variance, and the standard deviation. Let's calculate the variance and standard deviation first. So in order to calculate the variance, we need to take the sum of the square deviations from the mean and divide it by the total number of cases. And we can do that from a frequency distribution. Now, we could just use the raw data here, but we'll cut down on the number of calculations that we have to do if we first turn this into a frequency distribution. And we can do that by using Excel's pivot table. And so if we go to Insert, Pivot, we're going to put our table in the existing worksheet. And so again, we'll just pull this down to row labels. We'll pull this down to values. We'll change this to count to get the frequency distribution. To get rid of the Excel formulas, we're just going to paste over this using the paste special command. And basically, these are the values of the variable. Let's call the variable y. And so these will be the frequencies. Okay, so in order to get the deviations of the mean, we first have to calculate the mean. And we can do that by using Excel's built-in average function. So we don't actually go through and calculate the average. We can use Excel to do it for us. And so like we calculated in an earlier detailed example, the average education here is 14.1 years. So now we have to calculate the difference between each value of the variable and its mean. And so notice that I've put in this little, it's what's called a push or acute symbol. If I take this and make this a symbol, it'll put an overbar over the y, indicating that we're taking some kind of an average. And so we're just going to take the difference between each of the values of y subtracted from the average, and we're going to do this for each one. And so notice that M15 is the cell that's pointing to the average. If I put a dollar sign between M and 15, I can just put my cursor in the lower right-hand corner of this box, drag it down, and it will take the deviation from the mean for each of the categories of the variable y. So the next thing I need is the square deviations from the mean. And so if I take this and just make it a superscript, that'll indicate that I'm squaring. And so I take basically each of these values of the deviations to the mean for each category and square them. And again, I use the caret 2 to indicate the squaring operation. So I'm going to square each of these, and that gets rid of the negative numbers. And so now what I'm going to do is I'm going to take the frequency and multiply it by the square deviation. So we'll just have the square deviation from the mean. And again, if I just make this acute or push sign, if I change its font to symbol, it'll give me the overbar. And if I make this 2 a superscript, that'll look more like a square sign. Okay, there we go. So now what we're going to do is we're going to take each of these square deviations to the mean and multiply them by their frequencies. And if I put my cursor in the lower right-hand corner and I pull it down for all of them, that'll weight each of the square deviations by the frequency. And now what I do is I take the sum of the square deviations from the mean weighted by the frequencies. It gives me 137.8. And if I divide that value by the number of cases, or 20, minus 1, that'll give me my variance, which if I round to 2 decimal places is equal to 7.25. And if I take the square root, using the Excel square root function of the variance, I'm going to get my standard deviation. And again, if I round this to 2 decimal points, I get a standard deviation of 2.69. So what does that tell me? Well, on average, people have about 14 years of education, with a little under 3 years of education as a standard deviation. So advancing this detailed example yet again, now we can find the range and the interquartile range for education. And in order to do that, we can once again create a pivot table. So if I highlight my variable and I go to Insert Pivot Table, I'm going to put it in my existing document once again. And so I'll just take education, pull it down to where it says row label and where it says value, and then change it from sum to count. And then if I copy and paste it, I can paste over it using just the values to get rid of the Excel function codes. So I now have a frequency row here, and I have my values of the variable in this column. And so I can take these frequencies and turn them into percentages by dividing each of the frequencies by the total number of cases, which here is denoted by cell N13, and multiplying it by 100. If I just put a dollar sign in between the N and 13, it fixes that value in place, so I can just pull down the cell and do the calculations for every one of the different categories. And these should sum to 100. Okay, it seems like that worked. Now what I can do is I can calculate a cumulative percent by taking a running total. And so basically I'm going to take the percent of the first one and carry it over, and then I'm going to take that value and add it to the percent of the next category. And I continue doing that until I've reached the end. And notice that should sum to 100. Again, I can just pull that down to get the values for each one. Okay, so now let's identify some of the values that we need to get the range in the interquartile. Right? So we're going to need the minimum. We're going to need the first quartile, or Q25. We're going to need the third quartile, or Q75, and we're going to need the maximum. And so the minimum, you can see from the table, is basically 10 because there's at least one person in that category. Alternatively, what we can do is you can use the built-in Excel function min, which just takes the minimum of a range of values. And so that should, again, equal 10. To get the 25th percentile, we're going to find the first value in the cumulative percent column that includes 25%. And so you can see that 40 is the first cumulative percent to be higher than 25. And so 12 is going to be our first quartile. Now in Excel, what we could do is we can type in percentile and then highlight an array of values. And with a comma, tell it which percent we want. We want 0.25. And so it comes out to 12. And so we can do the same thing to get the 75th percentile, but we have to change the 0.25 to 0.75. And so that's going to be 17. And we would have gotten the same number if we looked at the cumulative percent row and found the first one to include 75%, which again is 17. And then we have to get the maximum. And the maximum is basically found from the table. There's at least one case with 19 years of education. But we also could have used Excel's built-in routine, max, to take the maximum array of numbers. And so it comes out to 19. And so the range basically is just equal to the difference between the max and the min, which is just 9. And then the interquartile range is going to be the difference between the 75th percentile and the 25th percentile, which is just 5. And so that tells us that the number of years of education separating the person who's most educated from the person who's least educated is 9 years, while the middle 50% of the data are separated by only 5 years of education, indicating that perhaps some of the people who have very low values of education or very high values of education are distinct from the rest of the distribution. Advancing this detailed example forward just again, if we calculate one more statistic, that is the median, we have enough to create a box plot. And so to get the median, we can do one of two things. We can look at the cumulative percent column to figure out which is the first to include 50%. And so notice that that's 13. However, because this is exactly on 50, the median is actually in between this category and the next highest category. And so we just average these two because this is an interval ratio variable. And so the median we will get is 13.5. The other thing we can do is we can use Excel's built-in median function. And so we just type in median, and we put in our value of numbers, and it gives us a median of 13.5. So now, unfortunately, Excel does not have a built-in routine for creating a box plot, but we can trick it into making one from a stacked bar graph if we make a column of difference values. And so here's what we do. We start by carrying over the minimum. And for the next cell, we're going to take the difference between the 25th percentile and the minimum. And then we're going to take the difference between the median and the 25th percentile. And then we're going to take the difference between the 75th percentile and the median. And finally, we're going to take the difference between the maximum and the 75th percentile. And so if we highlight these values, and we go up here to Insert, Column, and we do a stack column graph, this is what we're going to need. So notice here that Excel has created a graph, although it's not the one that we want. And so we have to change this a little bit. So if we click here, and then we right-click, and then we go to Select Data, all we have to do is go up here and select Switch Row Column. And so this looks more like what we want. We'll click OK. Okay, now we have to basically edit some of these values to make them look more like a box plot. So the first thing that we're going to do is we're going to go to the first series, and we're going to right-click, and we're going to hit Format Data Series. And we're going to go to Fill, and we're going to hit No Fill. And then we'll hit Close, because we basically want this one to be gone. Now for the next series, we're going to do the same thing. But before we do that, we'll go up here to Layout, and then we're going to add an error bar. And we're going to go to More Error Bar Options. We're going to use a minus error bar. And down here, we're going to go to percent and type in 100%. And then we're just going to click Close. that's going to make an error bar extending from the 75th percentile down to the minimum. And so this is going to be our lower whisker. And so again, if we go to Format Data Series and Fill, we're going to have no fill for this series as well. And so basically all we have now here is a whisker extending down to the minimum from the 75th percentile. Now for the top value, we're also going to make that a no fill series. And so we go to Fill, No Fill, we'll hit Close. And then we'll go to our second to last series, and we're going to add another error bar. So here again, we're going to go to error bars and under Layout, more error bars. This time we're going to make it a plus error bar. But instead of making it a percentage error bar, we're going to go to Custom, and we're going to go to Specify Value. And this is where we're going to specify our difference between the maximum and the 75th percentile. And we'll hit Close. And so now what we should have is a box and whiskers plot that has a whiskers going from the 75th percentile to the minimum, and the 25th percentile to the minimum, and the 75th percentile to the maximum. Now we can do some things to sort of edit this and make this look a little bit better. For one thing, we can get rid of this series. We also don't need this number here. We could actually get rid of it or change it somehow if we wanted to. But we could make the look of the box plot look a little bit better. And so one thing we could do is we can basically just change the colors here. And so if we click inside here, we can right-click it, and we can format data series. We can put a border around it. Let's use a solid line. We'll make it black. And then if we just click Close, that'll put a border around it. We can do the same thing here, format this data series, put a border around it with a solid line of black. And now if we click up where it says Home, the Home on the ribbon, we can change the colors so that they're gray. And we can do the same thing for this series. So now we have something that looks more like a traditional box plot. And so we can just add a few things. Again, if we just kind of go to Insert, we add a text box. We can put that up here. We can add a title. Our title is going to be, maybe Figure 1 box plot of education. We can resize our title a little bit. We can resize our chart area to make it a little bit smaller. We can delete the, whoops, don't want to do that. We can make this a little bit higher, maybe a little too high. And then we can put in another text box that will include, whoops, our source information. So let's say source GSS 2012, and then n equals 20 cases. Just move this up a little bit. And unfortunately, our source information doesn't seem to be cooperating so well. There we go. Whoops. Make it a little bit bigger. There it is. Okay, and so we have a pretty good-looking box plot. So we can basically describe the pattern here. This looks like a fairly symmetrical distribution, although the median's a little bit closer to the first quartile than it is to the third quartile. It's fairly close to a symmetrical distribution. And so our best choice of measure of variability in this case would probably be either the standard deviation of the variance, and of course the variance is not in the original metric of the data. The standard deviation is in the original metric. So we're better off choosing the standard deviation than we are choosing the variance, and so that's probably the best choice in this case.